Okay, this is 5th grade lesson 612, dividing by decimals on page 227. Buckle up, this is going to get really interesting. It's not just dividing by decimals, this will be dividing by decimals using equivalent problems. So let's talk about what equivalent problems means. So an equivalent problem means it's referring to when we're talking about dividing or multiplying by different numbers that equal the same thing. So, for instance, if I were to ask you, what is 9 divided by 3? Let's start there. Dividing or multiplying. This will work. 9 divided by 3 equals 3. But let's say we multiply the 9 by 10 and the 3 by 10. What's 9 times 10? 90. What's 3 times 10? 30. Does anyone know 90 divided by 30? The answer is still 3. That's the magic. What if we did 900 divided by 300? That would be multiplying both of these guys by 100. What do you think 900 divided by 300 equals? Still 3. What if we multiplied both of these by 1,000? 9,000 divided by 3,000. How many times does 3,000 go into 9,000? 3 times. By now you guys should be noticing a pattern. As long as you multiply both numbers by the same thing, your answer is going to end up being the same in the end. Okay? Multiply both of them by 10, you still get 3. Multiply them both by 100, then divide, you still get 3. So we're going to take that strategy and use it with decimals today. Okay, so here's the problem I'm going to start you off with. It's not going to be from the journal because the journal only gives you 2 opportunities to work on this and practice. So I would like to leave those open for you to try on your own. I'm going to give you one that's a lot like number 1, just with different numbers. So we're going to start with 4.68 divided by 1.3. And if you're asking yourself, why are we doing this? We just did this in section 611. Well, the difference here is instead of doing a decimal divided by a whole number, this time we're doing a decimal divided by a decimal. Okay, so hold this thought. This is our problem. Let's take a look at the first thing they want us to do. And they say, for problems 1 and 2, write an equivalent division problem that has a whole number divisor. Be sure to multiply the dividend and the divisor by the same number. So I want to clue you guys in here. The second number in a division problem is called the divisor. So they're saying we need to multiply our second number here, our divisor, by something that will turn him into a whole number. And all they said is make sure whatever you multiply him by, you multiply this person by 2. For instance, when we multiplied 3 times 10, we also multiplied the 9 times 10. That's what allows us to retain this equivalency, the same answer. If you do the same thing to both sides, you'll still get the same answer. So we need to figure out what we can do to this 1.3 to get him, to basically transform him into a whole number. And I have good news. This is going to be a callback. But earlier in the chapter, we found out that every time you multiply by a power of 10, the decimal point moves 1 spot to the right. So if we did, for instance, hopefully this is on screen, yes it is, 1.3 times 10 to the first power, which is basically just times 10. Take a look at your exponent, which is 1, and that will tell you how many places your decimal is going to move. So in this case, 1.3 times 10 to the first power tells us to move this decimal point 1 place to the right. And what number do we get if we move the decimal one place to the right? We get 13.0, or you can take the decimal and the 0 away, and you just have 13. So did we just turn our divisor into a whole number? We did, by multiplying by 10 to the first power. Okay, so we only had to move one spot, so we only had to multiply by an exponent of 1. But remember, there's something else we need to do. They told us, be sure to multiply the dividend and the divisor by the same number. That means if we multiplied 1.3 times 10, that's our divisor, we also need to multiply the 4.68 times 10. And we can follow the same strategy here. Times 10 to the first power, which is just like normal 10. We need to move that decimal one spot because the exponent is just 1. And that means our new dividend is going to be 46.8. Okay, so next step. Our new problem is our equivalent problem is now going to be 46.8 divided by 13. So now we're basically where we found ourselves in lesson 611. Now we're taking a decimal and dividing by a whole number. And we can do this. We just worked on this in 611, or at least we've started to understand how to do this. If you're not a master of this craft yet, it makes sense. We just started this. But now let's focus on how we can find our answer to a decimal divided by a whole number. So let's see what they tell us to do next. Make an estimate for your equivalent problem. So let's take 46.8 divided by 13, and can we estimate to make this a little bit easier on ourselves? Can we round 46.8 to something that works a little bit easier for us? And you know how I love my tens. I'm going to round him up to 50. Can we round 13 to something that's easier to divide by? 50 divided by 13 is not going to be a fun time for me. What if we just did 10? How many times does 10 go into 50? 5 times. So our estimate, I'm just going to use an EST, equals 5. Okay, so let's go back to our rules. We have write an equivalent division problem. We did that by multiplying each number by 10 to the power of 1. So we could turn him into a whole number. Next, we made an estimate. Nailed it. Third one, just like 611, it says divide as if the dividend were a whole number to solve your equivalent problem. So now we're going to take our dividend, which is 46.8, and just pretend that he's a whole number. 46.8 will turn into 468 divided by 13. This is going to be an interesting one. Remember, let's think of tens and things that end in zeros when we're talking about taking chunks off of this answer. For instance, I know 13 times 10. You can do this in your head or with your fingers. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. I'm going to start with 10. Take away 130 at a time. We get 338. I'm going to take another chunk. Well, I'm looking now. If we doubled this, if we did it by 20, do you know 13 times 2? It's 26. We could do that. We could take 260 off, guys. And sometimes when you play around with these numbers, you'll notice that those, you might not think of it the first time, but as you go, you're like, oh, I can take a bigger chunk off. 13 times 2 equals 26. Add the 0. 8 minus 0 is 8. Can't do 3 minus 6. I'll need to borrow. I can do 13 minus 6, however, and that is 78. Okay, so now this is where it gets a little tricky. How many times can 13 go into 78? I know 13 can go into 26 twice. That's cool. Maybe we'll stick with that. We'll just take away 26. I still in the paper. And this will show you how you can really work this piece by piece if you need to. And if you're still only comfortable with 13 times 2, let's take another 26 off. Oh, I notice something coming up. I just noticed a interesting moment here. Let the borrow. 12 minus 6 is 6. 4 minus 2 is... This is what I noticed. We're left with just 26, which we already know. 13 goes into 26 twice. So 26 minus 26, we don't even have to do that math. We know that's going to be 0. All right, so let's take a look on the right-hand side. This is what we have, a 10, a 20, and then 3 sets of 2. 10 plus 20 is 30, and then 32, 34, 36. So we have an answer of 36. Okay, let's go back to page 227. What do they want us to do next? All right, so we wrote an equivalent problem. We made an estimate for your equivalent problem. We divided as if they were whole numbers. So now we're right here. We need to estimate to place the decimal point. Or we need to use the estimate to place the decimal point. So our estimate was 5. And our answer with the whole number division was 36. And ask yourself, is 36 close to 5? And you might say, well, kind of. It's 31 away. So let me ask you this. Is there a place we could stick a decimal point that would get us even closer to 5? Okay, can we get even closer than 31? And obviously, decimal point here would be 36, 31 away. But what if we tried a decimal right between the 3 and the 6? Is 3.6 closer to our estimate of 5 than 36? And the answer there, of course, would be yes. So we took a look at our estimate of 5 and we said, all right, what can we do with a decimal to get this guy pretty close to 5? We plugged them right in there. And do we have anything left? Complete the number sentences to show the answers to the equivalent problem and the original problem. Cool. Yeah, so we would have to write an equivalent problem, which we did. It was 46 divided by 13. 46.8 divided by 13. And then we also had the estimate, which was 50 divided by 10. The estimate was 5, and the answer here we decided was, just like we found out down below, 3.6. This is a tough one, guys. I have about a minute and a half left. Maybe I can try to help you out on number 1 real quick, not the whole thing, but maybe we can find an equivalent problem, because that's going to be the trickiest part. So let's take a quick look. I'll put my work here. If you want to freeze, I'll try to zoom out so you can see the whole thing. This is my work for the example problem. And now here is what we can do for our page. To find an equivalent problem for number 1, it looks like we need to move the decimal point 1 place. So we can do that. That looks to be an exponent of 1. If you multiply both of these by a power of 10, 2.79 times 10 to the first means move this guy 1 spot. And that turns into 27.9. And 0.9 times 10 to the first would equal just 9. So your equivalent problem is going to be 27.9 divided by 9. All right, running low on time. Review what I worked on to start to try to finish the number 1. I will talk to you guys next lesson. Goodbye.